everybody. Jamie Zachary here again from Solex Thermal Science. Thanks for joining us for another episode of The Exchange. As usual, I have brought two very special guests with me. I want to first introduce Joe Marinelli. Joe, thanks for joining us. Tell us a little bit about yourself.
All right, Jamie. Well, I started my career a very long time ago, in 1972, with a company called Jenneke & Johansson. My company now is called Solids Handling Technologies. We're powder handling consultants located in the United States in a small town called Rock Hill in South Carolina.
On the other side of the virtual table, we have Albert Bedell. Albert, I joke that you've been at Solex forever. You've done about everything, and that's not too far from the truth, but tell us a little bit about yourself.
So my name is Albert Bedell. I'm currently the Regional Sales Director for the Asia Pacific region. However, as Jamie mentioned, I've worn a lot of different hats over the years at Solex, and I'm always interested in helping to learn about and really provide more information around new applications and new things that can be done with our equipment.
When we're talking about powders and batteries, what exactly are we talking about? And maybe Albert, I'll start by throwing that one to you.
When we think about batteries as consumers, at least for me, the first thing that comes to my mind is, a little Energizer cell. But really, when you get inside of those batteries, outside of a lead acid battery in a car, a lot of them are made up of essentially powdered chemicals that are working to, serve as the basis of the chemistry that's actually driving the energy storage. The main kind of technology that's driving things forward right now is lithium-ion batteries. You have a group of materials that are used for the cathode, group of materials that are used for the anode, and really those materials have to be handled in a powder form prior to being turned into those little silvery cells that we're so familiar with.
Yeah, my experience with batteries is handling the materials, the cathode materials, and like lithium carbonate. The lithium-ion batteries is a particularly difficult flowing material. We've had instances where we tested a lithium carbonate product, and in order to prevent arching or bridging over an outlet and a hopper, required an opening 7 meters in diameter to get it. That's how much strength that it has. It's brutal to try and handle it, and so. Some of the other things are the alkaline batteries, as you mentioned, the AA and AAA batteries, those sorts of things. A project that I got involved with, never forget it. These people were turning out batteries to the tune of 8 million batteries in an 8-hour shift out the door. 8 million batteries in an 8-hour shift out the door. Can you imagine? And hundreds of hoppers and hundreds of feeders and things like that. And they were having some major segregation problems, which we'll get into in a little bit later.
Tell me about why is powder handling know-how so important in these applications that you've just talked about?
Well, I've been spouting this for many, many years. There's two types of flow patterns that can develop in a bin or a hopper or a silo, whatever you want to call the vessel that's storing the material. One is called funnel flow, the other is called mass flow. The definition of funnel flow is that whenever you take any material out, some material moves, the rest just sits dead or stagnant in that hopper. Now this can lead to arching problems, bridging over the opening, not allowing the material to flow, to back everything up in that silo or hopper, to rat holing, where when that flow channel forms, usually forms down through the center. It doesn't have to, but it usually forms down through the center and creates a hole that's called a rat hole. The other flow pattern is called mass flow. And the definition of mass flow is that whenever you take any material out, everything moves. So that means everything in the whole hopper, silo, whatever, is all moving. This is the better way to handle a lot of products. In my career, since 1972, I'm guessing that about 85% of the materials that I've dealt with over the years require mass flow for one reason or another.
Absolutely. And I think that, in the context of dealing with these battery materials, what Joe is talking about here is super important because, when we're talking about lithium-ion batteries in general, yeah, the cost has come down a huge amount in the last, 15, 20 years. But the actual material costs are still a huge component of the actual finished battery. And these materials are incredibly valuable, and really, really a lot of thought, detail, attention has gone into making these powders just right. So they've been specifically blended, they've been specifically treated. And so if you have, as Joe mentioned, a funnel flow situation where you could have powder, essentially sitting stagnant, or having segregation issues, then what you're doing is you're essentially taking all this incredible value that you've built up in this powder and potentially just wasting it.
Segregation is a major concern in a lot of industries, pharmaceutical industry, you name it, and any industry. Roofing granules just on your shingles on your roof. All these granules, the colors and the sizes are critical to that shingle working properly, and so the particles of a solid tend to separate, especially if they're easy flowing. Okay, if they're easy flowing materials, they'll separate. When that happens, your process is now affected negatively. Those are the major.
I think that's a really great analogy there, Joe, mentioning a great way to think about this is it's kind of like the pharmaceutical industry. You have these high value materials. You are trying to get something from a powder form that's coming from some kind of crystallizer or, reactor, or whatever it may be, some kind of chemical process. You got this nice fine powder. You're trying to get it into a uniform tablet, and it's got to be perfect every time. And I think that's a really, really good, analogy to what we're dealing with here in the battery industry as well. You have these high value powders, really specific chemistries, and it's, coming out and it's being discretized into these little pouches, little cells, however you want to look at it. And it's got to be perfect. And if you start having segregation, like you say, the first half of the batch that you run, it's just that fine powder, the smaller particles. And then suddenly, the last third of the batch, suddenly you're dealing with coarser particles. Well, now that's going to throw off all your downstream processes. If you have, some kind of solvents that you're adding for a coating process or anything like that, suddenly you might have to change the amount of solvent that you're applying in order to get the same adhesion. And it's just going to throw everything out, throw a wrench into all your process.
Yeah, keep in mind, even if you ever took a 9-volt, I don't suggest doing this, but if you ever take a 9-volt battery apart, there's 6 little tubes in it. They're a 1/4 inch in diameter, about 1 inch tall, and they have to be filled volumetrically. In other words, you're not weighing the material going in. You have to fill it volumetric. So if you have density variations due to fines and coarse particles, that's going to affect what's in that little cell. And that's what causes the battery not to last as long, that sort of thing.
Absolutely.
I love how you guys can explain it in a way that you're getting down to a cell and taking it apart, and I can understand it. So love it. If I can understand it, let's be honest, everybody can understand it.
Just don't do that. Don't take a battery. So don't take the 9-volt battery.
just don't take the battery apart. No, fair enough. What are some of the processes or changes to the processes that could change how a powder flows?
One of the really key things to keep in mind when you're working with powders is that even slight changes to that powder can change how it flows, can change what kind of equipment you need to use with it to keep it moving through your process. So when it comes to, especially, battery materials, we're really still kind of in the infancy of the lithium ion battery chemistry. There's still a lot of work being done. So as, you tweak your formulas, maybe you're, changing slightly the composition of the powder, that can have impacts on how things flow.
Yeah, when we talk about segregation, I keep harping on segregation, but it's a big problem. One way to affect segregation is to add a little moisture to a material, or oil, or something like that, to get the fine particles to stick to the coarse particles. But the tendency with the industry is that more is always better. Well, you add so much moisture and so much oil, all of a sudden you got a real sticky, cohesive mess of materials. So a little bit, maybe, and won't allow the particles to segregate. Change the particle size. That's another way to do it. In other words, if you have fines and coarse particles, maybe you want to grind them down and make them roughly the same particle size. You get better, less segregation that causes problems.
And I guess one thing that, is close to home and I didn't touch on previously, but the temperature of the material. So anytime that a customer is working with a material and they know that there's going to be a change in temperature from, you're receiving it on a train car and goes through your plant, if it's not staying at the same temperature as it is in that train car, the flow properties could change. So, typically as things get warmer, they get a little bit easier flowing. There are limits on that. But certainly, you got to be thinking, okay, what is the actual temperature of the product that I'm receiving? What is the temperature that it's going to be at each point along the process? And how is that going to impact, the design of the hoppers at each stage along that process in order to ensure that we actually maintain that uniform mass flow?
Absolutely. There's really four things that affect solids flow. Moisture content. Increases in moisture content cause the material to become more cohesive. Particle size. The finer the particle, usually the more cohesive it is and troublesome. Time of storage at rest. In other words, you put it into a bin or a hopper and you go away for the weekend. You come back on Monday, push the button, it doesn't come out. What's going on? Materials gain strength as they sit there for a period of time. And temperature. Temperature is another one.
Absolutely. And I think, from, again, just the, the battery perspective, specifically handling lithium ions or lithium ion materials.
Right.
On the anode side, primarily we're working with, carbon graphite materials. They're relatively friendly when it comes to a fine powder, but certainly on the other side, and that side of the chemistry seems to be more stable. But certainly on the other side, the cathode powders, we're talking, incredibly dense materials, and the chemistry on that side seems to be more dynamic and changing more rapidly too. So certainly, as manufacturers are tweaking their cathode formulas, I think that's really where extra attention needs to be paid, or should be paid really, to making sure that, that material that might work great from a chemistry perspective, and it might work well in that bench scale in the lab, really has to work in harmony with that production line that's already out there in the field.
You can reach any information you need. You can see on our website, www.solidshandlingtech.com. And I know we're going to put it on the screen here, but on our website, we talk about all the stuff that we've been talking about today.
I think for anybody that's out there and wondering, they've got questions, like you say, first stop, definitely check out Joe's website, and definitely just get in touch with Joe or Scott, the team there at Solids Handling Tech. And, that's a great place to start, and a great place to just, like I say, learn, get some training, understand what questions you need to ask, and then you'll be able to understand what you need to do to solve those problems.
Perfect. Well, we're winding down our time here, Joe and Albert. I want to thank you both for your time today. I've certainly learned a lot. I hope everybody here who's tuned in has learned something as well. Joe, hope everything stays safe in your end. We stay in touch, and again, just thank you.
Thank you. I really appreciate the opportunity to meet with you guys. That's great. So.
Much appreciated, Joe. Always a pleasure talking with you.
Yeah.